is the way I live. Little boy still pushing big
Hey all,
bills.
Miss McKay here. So today we're going to be working on solving equations. Our goal when solving equations is to isolate a variable. Isolating a variable just means to get the letter all by itself, okay? To do that, we'll be using inverse operations. What an inverse operation is it's the opposite operation that's being done to the variable that we'll use to undo what's happening. Some vocabulary I'll be using are the addition, subtraction, multiplication, and division properties of equality. What that means is if you have addition and you're using the inverse operation of subtraction, for example, to undo it, you're using the subtraction property of equality. We'll get started in some examples. All right, our first problem today says 7x plus 9 equals 56. And our goal is to isolate the variable, means solve for x or get x all by itself. So the first step I like to do is draw a line right down the equal sign, because then it separates it into two spots, okay? The left-hand side of the equation and the right-hand side. So the first thing we do is we move the number that doesn't have a variable. In this case, it's positive 9. We are going to use our inverse operation to move plus 9 to the other side of the equation. So the opposite operation or inverse operation of a plus 9 is a minus 9. So we're using our subtraction property of equality to subtract 9 on both sides of the equation. On this side, well, plus 9 minus 9 is 0, so it cancels out just like we want it to. And 56 minus 9 is 47. So we'll write 56 minus 9 is 47. And let's rewrite the rest of the problem that we have. So we have equals 7x. So now we have a 7x, which just means 7 times x. We have to use the opposite operation or the inverse operation of multiply. The inverse of multiplication is division. So now we're using the division property of equality to divide both sides by 7. X is equal to 47 divided by 7 is equal to about 6.71. So let's leave it as 47 sevenths as our answer. Our second problem is negative 3x minus 2 equals negative 17. Again, first step, let's draw our line down the equal sign so we know the left-hand side of the equation versus the right-hand side. Our next step is we're going to use the inverse operation to move the number that does not have a variable. In this case, negative 2 does not have a variable. So the inverse operation of a negative or a minus is plus. So we're going to use the additive property of equality to add 2 to both sides. Negative 2 plus 2 is 0, so it cancels out just like we'd like it to. Negative 17 plus 2 is negative 15. And let's rewrite the rest. Now again, we have negative 3 times x. So we have to use the inverse operation of multiplication. The opposite of multiplication is division. So we're going to divide both sides by a negative 3. This is our division property of equality. So now x is equal to negative 15 divided by negative 3, which is positive 5. For our last problem, we have x over 2 minus 5 equals 25. Again, first step, draw your line to separate the left-hand side versus the right-hand side of the equation. Next, we want to move the constant, which doesn't have a variable. In this case, it's negative 5. We're using the inverse operation of negative or minus, which is addition. So we're using the additive property of equality to add 5 to both sides of the equation. The 5's cancel out just like we'd like, and we simplify 25 plus 5 is 30, and we rewrite the rest. Now in this case, our variable x is being divided by 2. Then we think, what's the inverse operation of division? Well, we know the opposite of division is multiplication. So to undo our division, we're going to multiply each sides of the equation by a 2. On the left-hand side, they cancel out, just like we'd like. We're left with x is equal to 30 times 2 is 60. So x is equal to 60.